Hello and good evening, everyone, and welcome to the April Recreational Astronomy Night of the RASC Toronto Center. My name's Tom Luton. I'll be your host for this evening. I apologize that we're meeting here online only instead of at our facilities at York University, but the weather outside tonight in the Toronto area is kind of frightful. We've had snow, we've had rain, we've got freezing rain, we've got high winds. So we've moved everything online tonight. So, presentations this evening. We have Arnold Brody at the Sky this month. Zakaria Belhaj will be talking about astronomy initiatives in Morocco. And unfortunately, because we've moved online, our third presentation, Ed Trace and I Want to Be Left in the Dark, will have to be pushed to May. Ed's presentation is fairly much an in-person presentation. So tonight's presentation, what this means is that after Scott, our president, with the announcements at the end, we'll be ending our show a little earlier than normal tonight. Anyway, but welcome to everyone joining us online, and let's get things started with Arnold Brody and the Sky this month. Arnold.
Well, thank you, Tom. Hello, everyone, and thank you for coming online to see what's up in the sky this month. We currently, as Tom just told you, we're currently having a lot of bad weather, but it will pass, right? And we can look forward to enjoying some of the astronomy highlights happening this month and into the first few days of May that I'll be covering. And these are the highlights for April and about a week into May. The first highlight is on April the 4th. It's the launch of our 2025 Millennium Square stargazing season along the shoreline in Pickering. I'm sorry, that was a plug, but I just couldn't resist. The next night, we get the first lunar occultations, not one or two, but five. Two of them occurring on the 16th. There's a difficult Mercury-Saturn conjunction on the 11th, but an easier one with the moon and Spica the very next night. There will be a mini new moon on Sunday the 13th. Mercury reaches greatest elongation west of the sun on the morning of Monday, April 21, and the Lyrid meteor shower peaks later that night into Tuesday morning. There will be a happy gathering of the moon, Venus, and Saturn before sunrise on April 25. And 2 mornings later, Venus reaches greatest illuminated extent and brightness. On Friday, May the 2nd, we have a daily double, our second star party at the square in Pickering. Oops, sorry, I did it again. On May 3, you can enjoy a close encounter of the moon with Mars along with that occultation. And there's a second meteor shower to round out the 35 days. The Eta Aquarids peak the morning of May 5. And April is prime time for galaxy hunting, for your deep sky observing and imaging. I like to combine astronomical twilight, when planets and bright stars can be seen, with night, and call that the observing window, which is 9 hours long tonight, but will shrink to just 7¼ hours by the beginning of May. That's a drop of 1 hour and 46 minutes. Night shrinks even more, losing over 2 hours to the sun as we enter May. So I guess one of the advantages of observing in April is that it's better than May, perhaps, and there are no mosquitoes. Dark skies will give way to a waxing moon next week with the full pink moon on the second weekend. Prime time for galaxy hunting occurs around new moon in the last weekend of April. Here, and prime time for galaxy hunting occurs at this time, and we get another first quarter moon on the 5th or 4th, I should say, of May. Now, the names given to the April full moon describe the end of winter or the start of spring. I especially like the broken snowshoe moon after the tough winter we just came through. Let's start our tour of the sky with the planets, with the solar system. And as of tonight, Earth, Venus, Mercury, and Saturn lie almost exactly on a line that is just west of the sun, meaning they will be rising in bright twilight. Neptune is not visible. It's still lost in the sun's glare as it rises. Meanwhile, east of the sun, Mars and Jupiter are visible in the west after sunset, with Jupiter a few hours ahead of Mars. And Uranus is also in the west, but much closer to the horizon, and will set soon after the sun. By the beginning of May, Earth, Venus, Saturn, and Neptune will still share a line, meaning the planets will continue to appear clustered together, with Mercury off to the left or east. Jupiter and Mars are still evening targets as Earth orbits away from both. Our view of Jupiter will be much closer to the sun, so the giant won't be up for long, and Uranus will be lost behind the sun by then. Tomorrow morning, with the sun only 4.5 degrees below the horizon, Venus, Mercury, and Saturn are low in the east, kind of clustered together. And Neptune is just beginning to rise. It's doubtful you will be able to see any of them except maybe Venus. Even that will be a challenge. The atmosphere will reduce its magnitude to 3, not -438, but -3. And that's a drop of 70% in brightness. By May the 5th, Neptune and Saturn have jumped up to join Venus in altitude, while Mercury is heading off on its own towards the sun, which is again shown 4.5 degrees below the horizon for comparison with the previous slide. Your chances of seeing Venus and Saturn are much better, but Mercury will be very low, losing most of its brightness to the thick atmosphere. But not so low for those observing from the southern hemisphere, where our ecliptic and planets' orbits stand almost vertically. On May 5, these 4 planets can be found 4 to 13 degrees higher in central Chile than in southern Ontario, and much easier to spot before dawn outshines them. Saturn, for example, here you see it's 12 degrees higher than what we will see from Toronto. And earlier in the morning, while it's before night transitions to twilight, from down south, Saturn will still be visible, so you can actually catch it at night. Mercury reaches greatest elongation west of the sun on Monday, April 21. For those down under, Mercury reaches its highest in the morning this year, and you can observe it before the end of night. That's something those of us up here in Toronto, I don't think we ever will get a chance to see Mercury in the night sky, but you can from south of the equator. And in Toronto, Mercury will be fighting through civil twilight when it's clearing the horizon. If the seeing is steady and the horizon free of haze, maybe you can see the phase of Mercury 3 days shy of dichotomy with high enough magnification. A minus violet filter may help reduce atmosphere-induced color fringing. 1 week later, Venus reaches greatest illuminated extent and its brightest for this morning star appearance. You can see Venus in its waxing crescent phase with enough magnification and good conditions. There will be no moon interference on that day. Again, a minus violet or fringe killer filter may help. Saturn will be too difficult to spot at the start of April as it clears the horizon. But by the beginning of May, Saturn will have pulled far enough west of the sun to make it observable in nautical twilight. We crossed through Saturn's ring plane a few weeks ago when it was hiding behind the sun. So we will get our first chance at early May to see the rings since then. The rings will remain thin and look this way all year. When the rings are close to edge on, with a modest telescope, you have a good opportunity to spot some of Saturn's moon besides Titan. You can subtract 1 or 2 magnitudes from those displayed here for atmospheric extinction, depending on how low Saturn might be at the time. But the rings will remain thin like this, and as Saturn climbs higher in the sky, it will become larger and brighter. It reaches opposition on the 21st of September, when the ball of Saturn will appear 20% larger and almost 1.7 times brighter. The same will apply to its moons as well. Neptune, like Saturn, will be too close to the horizon prior to sunrise to be visible in early April. But by early May, it might be possible to spot its tiny blue disk. But I'd say Neptune is not ripe for viewing yet. We might want to wait until August, when it will be easy pickings at the start of night. Turning our attention to the evening sky, after tonight's meeting, where it's not raining like it is here, you can find Mars holding hands with Pollux, Jupiter lingering between the horns of Taurus the Bull, and Uranus close to the horizon, west of the Pleiades. That's the moon next to Jupiter. All 3 planets are in prograde motion, heading eastward. Mars will cross from Gemini to Cancer in 10 days, while Jupiter continues to climb up through the bull's horns, and Saturn slips below the horizon towards the sun by the beginning of May. The angular size of Mars is under 10 arc seconds, which is considered the smallest size needed to see any detail. So Mars will simply be a fading, rusty dot until we finally lose it to the sun this fall. Being so big, Jupiter can still show some detail, though it will set soon after the sun by the start of May. In other words, this month is your last chance to observe Jupiter before it's too close to the sun, and we'd have to wait until it reemerges much later in the year in the fall. We are as far as we can get from Jupiter while still able to observe it. Jupiter reaches superior conjunction on June 24. If you observe Jupiter at 9 p.m. on Saturday, April 12, you can watch Io exit Jupiter's shadow. And even though Uranus is up briefly before sunset at the start of April, it'll be so low, our atmosphere will dim it below naked eye visibility. And that rounds out our tour of the planets. Let's move on to the moon. The moon will reach first quarter on April 4, just in time for Millennium Square. Now watch how the moon shrinks as it reaches apogee at the same time it reaches full, making this a micro full moon. I suggest you go out and have a look at it. You will never see a smaller full moon. Notice the moon approaching and enlarging as it reaches third quarter. And the darkening moon looms ever closer as it approaches perigee and new moon at the same time. That makes this a super new moon. Reaching into the first week of May, we have first quarter on May 4th. This chart plots April's micro full and super new moons at the peaks of the biggest oscillation of the apogee-perigee wave in 2025. If we're lucky and have a clear sky 2 nights from now, we can catch the lunar X and V. Mare Crisium is one of the targets in the Explore the Moon observing program. The best time to study this mare is when the sun's angle there is low, which occurs 2 nights after full moon. So instead of cursing the almost new moon, here's a reason to check it out. The Sea of Crisis has a very flat floor with wrinkle ridges called dorsa noticeable along its eastern shore. There is a small protrusion of mountains sticking like a thumb into the mare's west side. Look for a pair of ghost craters near the eastern shore of the mare, Yerkes and Licks, around 30 kilometers each in diameter. They are filled to the rims with lava. You can spot a few fresher craters around 20 kilometers wide or smaller, such as Picard, Pierce, and Swift. Their western rims will be brightly lit by the setting sun. And see if you can detect the pattern of light rays stretching across the floor of Mare Crisium. They are ejecta from the impact that dug out crater Proclus. The Blue Ghost Moonlander touched down in Mare Crisium on March 2, making Firefly Aerospace the first commercial company to soft land on the moon. After its official 2-week mission ended after sunset over that area, there was about 4 hours of battery life left, which the mission team saved and then turned back on at the right time to have the lander look back at Earth and capture this solar eclipse at the same time we were enjoying the lunar eclipse last month. A mass concentration, MASCON, or gravitational high, was identified in the center of Mare Crisium from Doppler tracking spacecraft on 3 gravity mapping missions. The monster asteroid that created this mare is hiding just under the lava plain. The sun. Well, it climbs the southern sky by 11 2/3 degrees from now to May 6. Its highest point is drifting eastward as our orbital velocity decreases as we pull away from our perihelion in early January. Our distance from the sun is exactly 1 AU today and will increase by 0.009 AU, which is around 1.4 million kilometers. That's how much it will increase from now till May 6. There was significant solar wind last week from a large Earth-facing coronal hole in the southern hemisphere that is now rotating out of view while another one rotates into view. Meanwhile, a very active group of sunspot regions is rotating into view. One in particular, active region 4048, grew rapidly as it swung into view and has a strong chance of producing flares with coronal mass ejections, CMEs, as it moves towards the meridian. Region 4048 has been classified as beta, gamma, delta, meaning it is complex with positive and negative spots mixed all over the place, including some positive negative charges inside the same penumbra. This is considered promising for CME producing eruptions. The latest notice from the Space Weather Prediction Center for this week includes radio blackouts resulting from regions 4046 and 4048, and geomagnetic storms this weekend from solar winds coming from coronal holes. Now, we are at solar maximum now, and we may stay there for a few more months. So the prospect for auroras remains good, along with radio blackouts for first responders and dispatch operators, and elevated radiation for airline personnel and frequent flyers. Comets. Well, there currently aren't any comets bright enough for easy observation. According to the Cernaver Observatory in Croatia, the only comet with reasonable magnitude, the first one, is not observable because it's in Pisces, where the sun is at the start of spring. So there are no bright comets for us to observe right now. But we can enjoy a couple of meteor showers. The Lyrids, or April Lyrids, is the first meteor shower since the Quadratids in January. The Lyrids are so named because the radiant is close to Vega, the brightest star in Lyra. The shower is debris shed by Comet Thatcher. The Lyrids have the highest zenith hourly rate, ZHR, from the debris of a long period comet. Thatcher has a 415-year orbit. Anything over 200 years is considered a long period. The prospects for viewing the Lyrids are very good this April. The radiant begins to rise soon after sunset and climbs almost to the zenith. A 24-day-old moon does not rise until 4 in the morning. The April Lyrids have the potential of producing fireballs, and outbursts occurred in 1992 and 82 when rates peaked at 90 an hour. And there was a famous outburst in 1803 with 700 an hour. That's like 12 a minute, or 1 every 5 seconds. That would be amazing. And it was a storm in 687 BC that caught the attention of Chinese observers who recorded it in a daily narrative Zuzan, like a Facebook of the time, making this the oldest known shower. The author wrote that the fixed stars were washed out by the brightness of the meteors that fell like rain at midnight, when the radiant is at its highest. By the way, here's the radiant of our next shower that's going to be rising here. It's the Eta Aquarids. It peaks in early May. The Eta Aquarids have a broad peak. Activity is good for a week centered around the peak, predicted for the night of May 4 to 5, Sunday into Monday morning. Here we see the radiant rising just before dawn on Monday, May 5. The first quarter moon sets a few hours earlier and will not interfere. This shower favors those watching from the southern hemisphere, where rates can reach 60 an hour, 1 a minute. Above the equator, the rate drops by half or more, 10 to maybe 30. It's debris from the famous comet Halley that creates the Eta Aquarids. And now grab your popcorn. It's time for Close Encounters. We have 5 lunar occultations, 3 conjunctions this April and early May. The first occultation is just 5 minutes into the start of Saturday, May 5, when the first quarter moon passes in front of 47 Geminorum. That's a fiercely hot main sequence star of spectral class A4. You may want to use moderate magnification around 120 or more to keep the illuminated half of the moon out of your field of view during the occultation. The next 2 occultations occur on the morning of Wednesday, April 16. The first occurs at the stroke of midnight, when the moon covers B Scorpii, not to be confused with Beta Scorpii. B Scorpii is an even hotter main sequence star than 47 Geminorum. This one is classified at B1. The bright limb of the moon will pass before the star, just as Monday night switches to Tuesday morning. The second occultation that morning occurs 5 hours later and is interesting because it involves an eclipsing binary whose stars are again hot class B1 stars almost at the very top of the HR main sequence branch. Consider the fact that there aren't that many major B1 stars throughout the galaxy. They live very brief lives, so the chance of seeing two of them together, that's crazy. And you're going to watch them being occulted by the moon. Together, they shine at magnitude 2.85, making Pi Scorpii the brightest of the 5 occultations. The occultation occurs just before 5 a.m. and ends just after 6, from 4:55 to 6:04. The Pi Scorpii binary orbit each other with a quick period of 1.6 days, a little under 1.6, at a separation of just 0.071 astronomical units. That's only 18% of the Mercury's average distance from the sun. So that is really very close. And they're very big stars, so their surfaces aren't that far apart. If we're lucky, the pair will be positioned like this, so we can see the double star disappear in 2 steps as the moon travels this way across the pair. And that would be great. Otherwise, if they're vertical, then they would just wink out at once. So with any luck, we can watch that occultation step down instead of just disappear. The fourth occultation coincides with a conjunction of the moon and Mars, with the god of war hanging out and chilling with the 7 sisters. With a wide field of view, you can watch a Salus Borealis wink out behind the dark limb of a first quarter moon in a sparkling scene with colorful Mars. The next night, we see the final occultation with 8 Leo, a faint 5.7 magnitude star, spectral type K1. The occultation will occur around 15 minutes to midnight and fairly high up. Use around 200 times magnification to keep the bright side of the waxing moon out of the eyepiece field. As for the conjunctions this month, the first on April 11 with Mercury and Saturn will occur in fairly bright morning twilight. It might be too difficult, unless, of course, you're south of the equator. Then they'll be up high in the sky, easy to see. The following day, you can easily watch the nearly full moon rise just a half a degree from brilliant Spica, which, by the way, is another, where is it here, B1 star. So I'm taking you to all the hottest spots. On Friday, April 25, at the start of your, you can start your day with a smile, with this happy face made by the moon, Venus, and Saturn, rising in civil twilight. Good day, eh? For deep space, springtime is galaxy time. If the ecliptic of our solar system were parallel to the galactic plane, we'd see the Milky Way in the night sky all year round. Instead, the ecliptic is tilted from the galaxy by 60 degrees. This means there will be seasons in which our nighttime sky faces away from our galaxy. Spring is one of those seasons when our view is out into intergalactic space. The hundreds of galaxies in this scene are all 12th magnitude or brighter. waiting for you to find them in moderate to large telescopes. You will usually find multiple galaxies together in your eyepiece. The concentration of galaxies next to Virgo's raised hand is the Virgo cluster, containing up to 2,000 galaxies around 54 million light years away. Among the cluster's members is a remarkable chain of 8 galaxies known as Markarian's chain, named after Armenian astrophysicist Benjamin Markarian, who, in 1961, published a report in which he used statistical math to conclude that they are not a chance alignment, but a real physical system. In the middle of the chain are 2 interacting galaxies, NGCs 4438 and 4435, coined the eyes by 19th century observer L.S. Copeland. The eyes look back at us with a slight squint because they are tilted just 15 and 20 degrees. The pair is number 20 in Halton Arp's catalog of peculiar galaxies. Peculiar primarily due to 4438's distorted shape caused by interactions with neighboring galaxies in this dense region. 4438 was robbed of significant gas and dust, cutting off future star birth. I mean, you can see here this massive amount of dust that has been ripped right out of the galaxy, along with all of this gas that's flying around that was pulled out, likely due to a high-speed collision with M86. A bridge of ionized hydrogen connects the two. Meanwhile, neighboring NGC 4435 was once a barred spiral galaxy. 100 million years ago, it passed within 16,000 light years of 4438, and the tidal interactions transformed it into a barred lenticular galaxy and ignited starburst activity in its central region. You don't normally find brand new stars in the galaxy's center, but that raises its brightness to what we see now. And the faint nebulosity surrounding both galaxies was recorded in this sketch of the eyes by Michael Geldorp in the Netherlands, using an 8-inch reflector. Gives you an idea what you might expect. The new moon weekend of April 26 and 27 will be a good time to have a staring contest with the eyes and see if you can detect any of the nebulosity around them, especially NGC 4438. They will appear similar in brightness, with 4438 not as narrow, tilted about 5 degrees more than its companion, 4435. And that's a wrap. That's all I've got for tonight. Are there any questions?
All right. All right, then. Well, thank you very much, Arnold, for a wonderful look at what's coming up in the sky this month. Do we have any questions from our online audience?
Well, there was one question. There were a few comments. Grace said that one part of your presentation reminds. Hello, can you hear me? Yes.
Grace do, yes.
One part of your presentation reminds her of one magical night when Tony, Brianna, and Tom were at the CAO, and Tom showed Brianna the moon. He used the moon atlas too. She still speaks fondly of it. Also, I love your sound effects, and I was wondering how many decades or centuries or millennia can we expect a meteor shower to last? For example, the Perseids.
You know, I would imagine that it's pretty close to indefinite, as long as the meteor streams left behind by those meteors don't get perturbed out of space, out of their locations by, let's say, the planet's gravitational tugs on those streams. Sometimes they do move. The streams will change based on certain harmonies with the planets. So I guess they will eventually drift, and maybe a different meteor stream will drift into our orbit instead. So you got to remember that these orbital paths that the comets take are terrific, and the debris that they leave are on the same orbit. So they will follow way out and come back. All of that debris, it's all in the same orbit. And as long as we continue to fly through that debris field, we will have the meteors. So it's up until such time as the meteor streams get perturbed out of our orbit. Until then, it'll always happen, I would say.
Yeah, and are
That's
the
my best
comets
answer.
in a constant state of disintegration, or is it a?
They are constantly disintegrating, and eventually, if they're close enough to the sun, they will lose enough material that eventually they've run out of volatiles. Sometimes they get so close to the sun that they get torn apart, and then they will disintegrate rapidly. But the debris field will continue to circle around and around and around. So the comet could be gone, but we will still pass through whatever it left behind.
Eric Briggs just had a comment. Pi Scorpii, that would rock.
Yeah, we've got so many stars in this presentation that happen to be B1. I mean, they're some of the biggest stars on the HR diagram that are still main sequence. They don't last for long, 100 million years maybe. So the fact that we've got so many lined up for looking at this month is remarkable.
Okay, that's it for the questions and comments.
All right. Well, thank you once again, Arnold, for a wonderful presentation. Okay, so we are going to go on to our second speaker now. So Zakaria Belhaj will be talking about astronomy initiatives in Morocco. Take it away.
Okay, thank you very much. Good evening, everyone. My name is Zach. I am a member and volunteer at RASC Toronto. We'll present you some initiative in astronomy initiative in Morocco. We'll start with the key initiative what we have in Morocco. The main observatory, its name, it's Lucamden Observatory, just started in 2007, located and 2,800 meters in Lucamden, and it's in Atlas Mountain. It's near to Marrakesh. It's a famous city, touristic city in Morocco. The main projects and collaboration what we have in this observatory, it's a MOS telescope. It's a collaboration with Switzerland and France. It's just a small telescope, just half-meter telescope for small solar system bodies. They have these of small bodies. And the major collaboration with the university, Liège University, it's the TRAPPIST North telescope. It's for detecting transiting planets and comets. And we will show you the major discovery using this telescope. Another collaboration with USA for monitoring space weather. Another small telescope with South Korea for satellite reentry and small bodies. And with Saudi Arabia, we have a collaboration studying lunar and solar observation. And with Australia, we have a collaboration in natural camera in Morocco to study meteor detection. Another collaboration with Spain, it's the sky brightness measurements. In Morocco, we have some stuff installed in this observatory. And the last collaboration, it's the professional amateur observatories. We have High Atlas Observatory. I am a member of this collaboration with the Camden Observatory and Atlas Sky Observatory. And the last one is it's Hawk Observatory. And recently, we have a collaboration with Russia about space debris monitoring. We have 3 telescopes installed. To have a look, this is the Camden Observatory and all the stuff installed there. Some images for the material. It's the TRAPPIST, the ASHO and that's our observatory, all the stuff installed in looking. Just to have an idea. This one is High Atlas Observatory. I said this, I'm a member of the team of this observatory. We installed this observatory in 2021. We have 6 pillars, accommodate 6 telescopes. We use it for astrophotography and doing some science with professional in the observatory. Here we observed the James Webb Space Telescope after launching, and we have images of the observatory, which we can see the telescopes and everything, every stuff in the observatory. The telescopes what we have, those 6 remote telescopes, we can use it everywhere in the world. Just we need to connect and use the telescope remotely. We have some telescopes, some plane wave, some Takahashi, some to have an idea about the telescopes and the mounts. Using this telescope, we detect a lot of things. We have searched asteroid, exoplanet, and gamma ray brass and Kiranova space junk. And for sure, we do astrophotography using these telescopes. In Camden, using the TRAPPIST North. We have 2 TRAPPIST South in Chile and TRAPPIST North in Morocco in Camden Observatory. We remember the big discovery of 7 Earths, 7 exoplanets around TRAPPIST star. This is the discovery. It was published in Nature journal, and we see that we have 3 Moroccan researchers participate in this major discovery of the 7 planets. Other researcher published in Nature using our telescope in Camden. Here about asteroid, and the other one about trans-Neptunian object outside its Roche limit. Another discovery about the M6 star. And about light pollution it's another publication in Nature Journal about the Blue Walk tree satellite. And for sure, a lot of asteroid detection using our telescopes. And since then, the asteroid detection companies have succeeded a lot of sessions per month, and currently the observatory has over 1,000 asteroids detected. We use our material to detect exoplanet, transition exoplanet with it and characterization of this planet. We show this characterization using our small telescopes in Locandon Observatory. Here it's the gamma ray burst, the optical parts of the effect. And for sure, we are amateur and we like astrophotography. I will show you some images using our telescopes. Here, for first images, we installed the telescopes in 2021. Another image, some galaxies. And here it's another nebula. The Squid Nebula. And Spaghetti Nebula, it's a huge nebula. We use our telescopes to shoot this beautiful object. Recently, in 2025, friends from the observatory, they published upon NASA. It's the region of Spaghetti Nebula. And we installed a new telescope, a new dome. It's a plane wave telescope with 500 millimeter telescope and the mount L500. It's now installed and we use it to do some discoveries and astrophotography. The first object photographed with this telescope is Helix Nebula. We can say a lot of details in this nebula. Here it's the Horsehead Nebula. It's very beautiful when we see the pictures from Hubble or some big telescopes, and we see our small telescopes show the quality of the sky in Camden Observatory. You can say a lot of details in this nebula. Now it's another new observatory. It's the same like High Atlas Observatory. It's Hawk Observatory, High Atlas Window to the Cosmos. It's a private, and everyone in the world, you can put his telescope and you use it remotely. Now we have per year approximately up to 240 clear nights, and the average seeing it's 1.2 arc seconds, and you can rental a pier or put your telescope in this observatory. If you need any information, we have here the websites and the email. Now, actually, I check with the team. The website is under maintenance. Maybe it will be live next week. But we have the email if you want to contact the team. Maybe you can put your telescope in this observatory because it's when we have daylight in Toronto, it's night at Morocco, and you can observe or do astrophotography daily, and we can show the sky objects for outreach, for public outreach, or in school during the day using this platform in Morocco. Because when I mentioned that when we have day in Toronto or in Canada, it's night in Morocco, and we have clear sky approximately all the year. We have a clear sky in this part of Morocco. Here it's new nebula discovery of nebula using this platform. It's Atlas Nebula, recently discovered by the team. And for sure, we have some initiative about education and awareness. It's me here who do some activities with students in the school, and we have some festival in Morocco. We have 3 major astronomy festival in Morocco, 3 cities. Every year we organize these activities to share with public what we love and about astronomy, and all the things about outreach or educational things in astronomy. We have also astrotourism in Morocco, a popular destination for stargazing. It's a place we call it Marzouga, or Agafay Desert, or Atlas Mountain. You can go. The images what we see, it's Marzouga. We can say the desert here, and we can go and do stargazing or sunset or sunrise. It's a huge and beautiful place to see the sunset and sunrise, and for sure the stargazing during the night. Here we say 3 people, but the person in the middle, I don't know if you know it or not. He visited our observatory, I think, in 2 years ago. Is Michel Mayor, is a Nobel Prize in physics. He visited our observatory, and it was an honor for us. That person visits our observatory, and we discuss a lot of things about exoplanets and about astronomy in general. Thank you very much for your time.
And thank you very much for the great presentation of astronomy in Morocco. Betty, do we have any questions?
Betty.
Yep.
You're on.
Oh, yes, we do. Oh, sorry. Well, we have a question which I think was answered. We have a couple of comments. The first comment is from Saif, your son. Go, Dad, you rock.
Okay.
And
thank you. Thank you, Saif. You too,
the
you rock.
question was, sorry,
Yeah.
just a minute. The question
No
is,
problem.
and I know you answered it, but it's worth repeating. Wondering how many nights per year of good viewing seems like an ideal location.
Yeah, the clear nights, it's between 180 to up to 240.
Yeah, and your son replied, also, the sky is just wonderful there.
Yeah, I know. We visited the
Yeah.
observatory many
And
times for sure.
Claude, Wonders of the Sky, said, "Great presentation. Wondering how does it work? Wondering how does it
Thank you
work
very
if
much.
you want to book imaging time from those remote observatories?"
Eh, Yes, I said the website is just in maintenance period. Maybe next week it will be live, and you can see all the details, how to book nights and everything about telescopes.
Okay, thank you. And that was all the questions. Well, thank you.
Thank you very much.
All right. And thank you once again. So, as I said at the beginning of our program, Ed Trace's presentation will be postponed until next month because, as I said, it's an in-person talk as opposed to one that can be conducted online, which brings our evening's presentations to a close. So now I'd like to bring up our president, Scott Masterton, who will give us our announcements. Scott?
Thank you, Tom, and hello to all our watchers out there in YouTube land. The announcements tonight first begin with me explaining what we're doing. Of course, you've just experienced our RAN, Recreational Astronomy Night. Normally, or usually, we try and do that in a hybrid fashion with people visiting the night in person and make it available online. Of course, because of the weather, we have changed that tonight, but normally it's a hybrid. And of course, Speakers Night. Speakers Night is a night when we invite learned astronomers to speak to us, and that is exclusively online. And they join us from, in some cases, all over the world. Of course, when we're using online, you can make comments, and that's how questions are proposed for the end of the discussion. And we would encourage you to use that. When on those days when we are attending York University, the Carswell Observatory is available for viewing every Wednesday evening. We would ask you to look at the join us online or look at the tour and make a reservation to get tickets at the indicated URL, or you can send Dr. Elena Hyde an email. Speakers Night in April next month, or sorry, later this month, is online only, as I've said. And Dr. Nadine Mansett, Director of the Science Operations at the CFHT, the Canada, France, Hawaii Telescope, will present a journey through space and time. To get information there, go to the URL. And the DDO Family Night, the Lyrids April Showers, that will occur Friday, April 4th, 8 to 10 p.m. And the description there indicates that you'll get a presentation on a variety of topics. Registration is as indicated, and you can find links on the rasto.ca website. Astronomy Speakers Night at the DDO, Friday, April 11th from 8:30 to 10 at the DDO. And the indicated information and costs are indicated at the bottom. Millennium Square, we've had a few plugs for that, and so I'll just do it once more. Millennium Square Public Star Party, enjoyable night. Look through our members' telescopes and visit the night sky there. The Carr Astronomical Observatory, our observatory up north, access is available now year-round. We're plowing the roads out, although now that doesn't seem to be needed right now. Masking is optional, and in order to book attendance there, go to the URL as indicated. And of course, if you want to join, you can do so at the national site, mempub@resc.ca. We also, once you're a member, you can volunteer to help us out. And we would encourage you to do that. If you have free time, you can assist us by going to volunteer@rasto.ca. A fun fact, what is the temperature of the sun? Well, it depends on where you are. At the core, it's a lovely 15 million degrees Celsius, pretty warm. And at the surface, or the photosphere, what we see, it's relatively cool at only 5,500 degrees. But then there's a surprise. The coronosphere, just above the photosphere, is about 20,000 degrees C, and further out, it's a remarkable 1 to 2 million degrees. Kind of confusing. We would ask you to have a good night, and thank you for joining us, and be safe. Keep looking up.